So a couple of questions that will help review for tomorrow's quiz. The first one is fairly typical here. They give you the graph of the derivative of the function, and that's the key thing to note. This is the graph of the derivative of the function. This is not the graph of the function. So if this is the derivative, then the y values on this graph are giving us the slope of the tangent lines. They're not giving us the y values on the graph. They're giving us the slopes of the tangent lines. So on this interval right here, the slopes of the tangent lines are all negative. So on the interval from here to here, we have negative y values on the graph of y equals f prime, and that means that we have negative slopes on the original function. Well, if the slope of a function is negative, that means that the function itself must be decreasing. So I don't know what this function looks like, but I know it decreases until I get to x equals negative 7, because that's where the derivative becomes 0. Then on the next interval here, the derivative becomes positive, and it remains positive until the x value goes to here, which is negative 1. So if we were to graph the function now, so the orange thing here is the function, the derivative is positive, which tells me that the function is increasing. The function's derivative, the y values on this part of the curve are still positive, but they're starting to get back closer and closer to 0, so that at 1, negative 1 rather, the slope would be 0. Now on the next interval, the derivative becomes negative again. Again, that tells us that the function is decreasing on this part of the curve right here, because all of those blue y values on the graph of y equals f prime are negative. So that tells us that the function is decreasing. And so on. So if we think about where do we have a horizontal tangent? Horizontal tangents occur when the derivative is equal to 0. So we'll have a horizontal tangent at negative 7, a horizontal tangent at negative 1, a horizontal tangent at 4, and a horizontal tangent of 8. So we can write that out. So the answer to part A would be f has a horizontal tangent at x equals negative 7, x equals negative 1, x equals 4, and x equals 8. Because f prime is 0 at each of those spots. And if the derivative is 0, that means we have a horizontal tangent line. Now some people will say, don't we have a horizontal tangent here? We do have a horizontal tangent on the derivative. So that would be a place where the second derivative is 0. Likewise, we have a horizontal tangent on the derivative here. So the second derivative, the derivative of the derivative would equal 0 here, and likewise at whatever this spot is right here. So then it says, part B, for what values of x on the interval do we have a relative maximum? Justify your choice. So when I think about a relative maximum, it might look like this orange curve here, where the derivative is positive, and 0, and then negative. So I'm looking for a place where the derivative goes from positive to 0 to negative, and we have the graph of the derivative. So in this case, the derivative is going from positive to 0 to negative. Here the derivative is positive because this is the graph of the derivative. It's above the x-axis here. The derivative is negative here. So we're going from positive to 0 to negative. So part B would say f, the function we can't see, has a relative max at x equals -1 and at x equals positive 8. This is because the derivative changes from positive to negative at these points. And if the derivative changes from positive to negative, then the function is changing from increasing to decreasing, so we'd be at a relative max. And then the last part, part C here, says for what values of x is the graph concave down? Well, a function is concave down when the second derivative is negative. Second derivative would be the derivative of the derivative. So when is the derivative of the derivative, or the slope of the tangent lines on the derivative graph, negative? Well, along here, the curve is rising, so its derivative would be positive. So the second derivative, since this is the graph of the derivative, the slopes along here would be the second derivative of f. On this interval from here to here, the slopes of the tangent lines would be negative. So if we estimate this point here to be at x equals negative 3, and we estimate this point here to be at x equals positive 2, we can say that f is concave down on the interval from negative 3 to positive 2, and again, the slopes of the tangent lines on f prime, so the second derivative, are also negative from 6 to 10. So f is concave down when the second derivative is negative. This is the graph of f prime, so f prime at prime, or the second derivative, slopes of the tangent lines would be negative from negative 3 to 2, and then negative from 6 to 10.